Assalamu alaikum friends. Today we will expand the function in Fourier series. The function is f of x is equal to x sin x, and the intervals are from minus pi is less than x is less than pi, means intervals are from minus pi to plus pi. First we have to check whether this function is even function or odd function. For this, we have to replace x by minus x. For example, first I have to write this function f of x is equal to x sin x. In this function, I have to replace x by minus x. So, f of minus x is equal to this x will be replaced by minus x sin into minus x. This is equal to this minus and this minus. This will become equal to plus. So we will get x sin x. So we can say that f of minus x is equal to f of x. Therefore, we can say that this function is even function. And for even function, we know that the value of bn is equal to 0. Now, in this case, we have to find the value of an and the value of a naught. In the equation of Fourier series, we have bn, an and a naught. In this case, the value of bn is equal to 0 because the function is even function. And we have to find only the value of a naught and a n. First, we have to find the value of a naught. Friends, we know that the equation for a naught is equal to 1 over L integration from minus L to plus L f of x dx, or we can write this equation as this is equal to 2 divided by L integration from 0 to L f of x dx. Here we have the limits from minus pi to plus pi. So we can write this equation as a naught is equal to 2 divided by pi integration from 0 to pi f of x dx. This is the equation for a naught. Now, in this equation, I have to put the value of f of x. So, this equation will become equal to a naught is equal to 2 divided by pi integration from 0 to pi. The value of f of x is equal to x sin x dx. Now, I have to integrate this one, and I will apply the product rule on this one. According to the product rule, this will become equal to 2 divided by pi into x minus cos. So I have to write here minus cos x, and the limits are from 0 to pi, plus according to the product rule, integration from 0 to pi derivative of this x, which is equal to 1, and this cos. So cos x dx, we will get this one. Now I can write this equation as a naught is equal to 2 divided by pi into minus x cos x, limits are from 0 to pi, plus integration of this one. The integration of cos is sine, so this will become equal to sine x from 0 to pi. So we will get this one. Now I have to put the limits, upper limit and lower limit. When I put the upper limit in this sin x, we will get 0 in both cases. The, the value of sin pi is equal to 0 and the value of sin 0 is also equal to 0. So this term will become equal to 0. And this will become equal to a naught into 2 divided by pi into minus pi cos pi minus 0 cos 0 plus this is also equal to 0. We will get this one. This term will also become equal to 0. So finally we will get a naught is equal to 2 divided by pi into minus pi cos pi. We will get this one. Here this pi and this pi will cancel and we will get minus 2 cos pi. And we know that the value of cos pi is equal to minus 1. So we will get minus 2 minus 1 is equal to 2. So we can say that the value of a naught is equal to 2. This is the value of a naught. Now we have to find out the value of an. Friends, we know that the equation for an is equal to 2 divided by pi integration from 0 to pi f of x cos nx into dx. This is the equation for an. Now in this equation, I have to put the value of f of x. So this will become equal to an is equal to 2 divided by pi integration from 0 to pi x sin x cos nx into dx. Now friends, I have to apply the trigonometric relation sin a into cos b is equal to half into sin a plus b plus sin a minus b. I have to apply this trigonometric relation on this sin x cos nx. So this equation will become equal to an is equal to 2 divided by pi integration from 0 to pi x. The value of sin x cos nx will be equal to 1 over 2 sin 1 plus n x plus sin 1 minus n x into dx. We will get this one. Now here these two and these two will cancel each other and we will get 1 over pi integration from 0 to pi x sin 1 plus n x into dx plus 1 over pi integration from 0 to pi x sin 1 minus n x into dx. We will get this one. Now here we have to apply the chain rule on this term and also on this term. And we will integrate. After integration, we will get an is equal to 1 over pi. If I take 1 over pi common, then it will become equal to minus x cos 1 plus n divided by 1 plus n x, and the limits are from 0 to pi. We will get this one plus integration from 0 to pi. The derivative of x is 1. So we will write here only cos 1 plus n x divided by 1 plus n into dx. Now I have to apply the product rule on this integration and we will get minus x cos 1 minus n divided by 1 minus n x, and the limits are from 0 to pi plus integration from 0 to pi cos 1 minus n x divided by 1 minus n into dx. Friends, when I integrate this integration, we will get this one. And when I integrate this integration, I will get this plus this one. Now friends, I have to integrate this one and this one. And we will get an is equal to 1 over pi into minus pi when I put the limits here. So we will get minus pi cos 1 plus n into pi divided by 1 plus n. And the integration of this term will become equal to plus sine 1 plus n x divided by 1 plus n square. We will get this one. And the limits are from 0 to pi. And again, when I put the limits on this term, minus x cos 1 minus n pi divided by 1 minus n, and the limits are from 0 to pi. So we will get minus pi cos 1 minus n pi divided by 1 minus n. And the integration of this will become equal to sine 1 minus n divided by 1 minus n square. Limits are from 0 to pi. Now, when I put this upper limit and lower limit in this one, we will get this term become equal to 0. This whole term will become equal to 0 when I put the upper limit and lower limit. And also this will become equal to 0. And finally we will get an is equal to 1 over pi into minus pi cos 1 plus n pi divided by 1 plus n minus pi cos 1 minus n pi divided by 1 minus n. We will get this one. Now I have to apply the trigonometric relation on this and also on this. The trigonometric relation is that cos pi cos n pi minus sin pi sin n pi is equal to minus cos n pi. So this cos 1 plus n pi, this is equal to minus cos n pi, and also this cos 1 minus n pi is equal to minus cos n pi. So this term will become equal to an is equal to 1 over pi minus pi into minus cos n pi divided by 1 plus n minus pi into minus cos n pi divided by 1 minus n. We will get this one. And this will become equal to an is equal to 1 over pi into cos pi cos n pi divided by 1 plus n plus pi cos n pi divided by 1 minus n pi. We will get this one. Now I can write this equation as that an is equal to 1 over pi into minus pi cos n pi divided by n minus 1 into minus pi cos 1 plus n divided by 1 plus n. We will get this one. Just I multiplied both the term by minus. So I have written this term here and this term I have written over here. So this equation will become like this one. Now this pi and this pi will cancel each other. This pi will also finish. So we can write this equation that this is equal to minus cos n pi divided by n minus 1 plus cos. This is a n pi. This is n pi. This is not 1 plus n. So I can write here cos n pi divided by 1 plus n. Now from here I have to take common. Cos n pi I have to take as a common. So an is equal to cos n pi into 1 n plus 1 minus 1 over n minus 1. So here I have to take the LCM. So after taking LCM we will get cos n pi into n minus 1 minus n minus 1 divided by n square minus 1. We will get this one. Here this plus n, this minus n will cancel and we will get an is equal to minus cos n pi. This is equal to minus 1 raised to the power n. And we will get minus 2 divided by n square minus 1. We will get this one. Now this can also be written as that minus 1 raised to the power n plus 1 into 2 divided by n square minus 1. So this is the value of an when n is not equal to 1. So we will get this value when n is not equal to 1. When n is equal to 1, if n is equal to 1, then the value of an is equal to 2 divided by pi integration from 0 to pi f of x cos nx. This will become equal to a1 means the value of n is equal to 1. So this will become equal to 2 divided by pi integration from 0 to pi x sin x and cos x into dx. Here the value of f of x is equal to x sin x and this n will become equal to 1. So we will get this one. Now I have to write this equation as that a1 is equal to 2 divided by pi integration from 0 to pi x sin x cos x. This is equal to sin 2x divided by 2. These 2 and these 2 will cancel. We will get 1 over pi integration from 0 to pi x sin 2x into dx. So I have to integrate this one and we will get a1 is equal to 1 over pi integration minus x cos 2x divided by 2 plus minus sin 2x divided by 2 and the limits are from here from 0 to pi. Now when I put the upper and lower limits in here and also here, then this term will become equal to 0 and we will left only this term and this will become equal to 1 over pi into minus pi cos 2 pi divided by 2 minus 0 cos 2 pi divided by 2. This is equal to 0. So this term will become equal to a1 is equal to 1 over pi into minus pi divided by 2. This pi and this pi will cancel and we will get the value of a1 is equal to 1 over 2. I have to put the values of bn, a0, an and a1 in the equation of Fourier series. And the equation of Fourier series is equal to f of x is equal to a0 divided by 2 plus summation n is equal to 1 up to infinity an cos n x plus bn sin n x into dx. This is the equation of Fourier series. Now we have the values of bn is equal to 0, so this is equal to 0, and I have to put the value of a naught, an and a1. The value of f of x is equal to x sin x, this is equal to 2 divided by 2, plus the value of a1 is equal to minus 1 over 2 cos x plus summation n is equal to 2 up to infinity. The value of an is equal to minus 1 raised to the power n plus 1 into 2 cos n x divided by n square minus 1. So the final equation of Fourier series will become like this one. So this is something about this function. Thank you.